So this is the 2015 Leaving Cert Higher Level Paper 2 and we're looking at question number 3. Part A, the coordinates of 2 points are A, 4 minus 1 and B, 7, t. The line L1 is 3x minus 4y minus 12 equals 0, and that is perpendicular to AB, which is the line joining A and B. Find the value of t. Okay, now the key word here is perpendicular. If two lines are perpendicular, we can say that their slopes, the slope of the first one multiplied by the slope of the second one is -1. That's a fact. So if we can find the slope of this line and then the slope of this line here in terms of t, obviously, we can multiply them, let them be equal to -1 and set up an equation. So let's get the slope of L1 first of all. Well, we need to do some rearranging there. The easiest way to find the slope is to manipulate this into the form y equals mx plus c, and then m will be the slope. So we're going to move the 3x over here, and we're going to move the minus 12 over here. It's going to give us minus 3x plus 12. So giving us minus 4y equals minus 3x plus 12. Then we're going to divide everything by minus 4. Try that again. Divide everything by minus 4. This by minus 4, and this by minus 4. And that leaves us with y equals minus 3 over minus 4 is just 3/4. X and 12 divided by minus 4 is minus 3. So we have there our m value is the 3/4. That's our slope for this line. Slope of 3/4. Now, the slope for this line here, we can use the slope formula, which is, so that's our M1, we'll call that for L1. Our second slope is going to be given to us by the formula y2 minus y1 over x2 minus x1. So we can call this point A, we can call x1 y1, and the point B we can call x2 y2. So we're just going to sub these then into this formula. So that's going to give us y2 is t minus y1, so t minus 1 all over x2, which is 7, minus x1, which is 4. So we tidy that up. T minus 1, that's t plus 1, over 7 minus 4 is 3. So t plus 1 over 3 is the slope in terms of t of the line AB. And then we're going to use this here to set up the equation, this fact here. The multiplication of the slope, so that's 3/4 multiplied by t plus 1 over 3. Because the lines are perpendicular, we multiply their slopes, we know we get an answer of -1 always. That's always true. So we're now going to multiply these fractions together, numerator by numerator. Careful here, the 3 gets multiplied by the t and by the 1. So that's 3t plus 3. Multiply the denominators. 4 by 3 is 12. That's -1. Multiply both sides by 12. Gives us 3t plus 3 equals -12. Bring this positive 3 over. Becomes negative. That gives us 3t equal to minus 15. And finally divide both sides by 3. That leaves me with t on the left is equal to minus 15 divided by 3, which is minus 5. So there we go, our value of t is minus 5. Okay, moving on. Part B. Find in terms of k the distance between the point P, which is 10 km, and L1, the line L1, which we've already been given. Okay, so if we want to find the distance between a point and a line, there's a formula in our tables book, which I have down here. So we just apply this formula here. Now, the line L1, if you remember, was uh, 3x minus 4y minus 12 equals 0. So the a, b, and c values in here, and the a and b values, are the coefficients of x, coefficients of y, and the constant, respectively. So, in other words, that's going to be our a value. Minus 4 will be the b value, and again they go in down there as well. And then the c value will be the constant negative 12. That's going to go there. And then the x1, y1 is the point, so that's going to be x1, y1, 10 and k respectively. So we're going to substitute these now into our formula. D is going to be equal to the modulus So it's the modulus of a, which is 3 times x1, 3 times 10, plus b is minus 4 times y1 is k, and then the c value at the end, negative 12, and that's all going to be over square root of a squared plus b squared. So that's going to be square root of 3 squared plus minus 4 squared. So tidying this up, 3 by 10 is 30, minus 4 by k is minus 4k, minus 12 still there at the end, all over. The square root of 3 squared plus negative 4 squared is 5. And so for a final tidy up, we have modulus of 13 minus 12 is 18 minus 4k all over 5. So that's, in terms of k, the distance between the point 10k and L1. Part C says P, again the same point, 10k, is on a bisector of the angles between the lines L1 and L2, and they give us L2 here. So L1 was the line before, and we're asked to find the possible values of k. Alright, so, well, let's just think about this visually. If that's L1, let's say this was L2, I'm just drawing these randomly now, and you know that the point 10, k is on a bisector of the angles between the lines. In other words, it's going to be somewhere here, the point P, somewhere on this line. Or indeed, it could be somewhere on this line here as well, which would also bisect the angles. And again, it could be above or below here, but just visually to represent what we're thinking. So if the point is on a bisector, that means it's equidistant. Its distance to this line would be the same as its distance perpendicular, distance that is, to the other line. And again, we're going to use, because we know that, we can use this distance from a point to a line formula. So we've already found the distance from P to L1, which was in our previous question. So we've already found that distance to be 18 minus 4k all over 5. So we're going to let that distance be equal to the distance from the point to this line, L2, and set this up as an equation in k and solve that for our values of k. So once again, we're going to carefully find our values of A for L2 will be 5. B value will be the coefficient of y, which is 12. And finally our C value will be the constant at the end, negative 20. Okay, so we're going to substitute these in. That's going to give us, again, obviously our 10 is our x1 and k is our y1 value for in here as well. So we have a times x1, that's going to be 5 times 10, plus b, which is 12 times k, y1, and then plus c, and our c value is negative 20. That's all going to be over the square root of a squared plus b squared, which is the square root of 5 squared plus 12 squared. Okay, so moving on then, we've still got 18 minus 4k all over 5 on the left, equal to 5 tenths is 50. That 50 minus the 20 gives us 30. Plus 12 by k is 12k. All over the square root of 5 squared plus 12 squared. Do this in your calculator. That gives you 13. So there we have it. Now, just be careful here. Because it's the modulus of something equal to the modulus of something else, you have to account for the possible positive or negative aspect of that. So this is a fraction equal to a fraction. So we're allowed to cross multiply here. But as we cross multiply, we have to take into account what I just mentioned, the positive, negative aspect of modulus. So 13 multiplied by 18 minus 4k will be equal to the 5 times the top of this. So 5 multiplied by 30 plus 12k. But because of the modulus being equal to the modulus, you have to say it's plus or minus that. So we work out the left. We have 13 times 18 here, giving us 2, 3, 4, minus 4 by 13 is 52, so minus 52k, equal to plus or minus 5 by the 30 is 150. So here actually it should be, we'll do it with plus first. We'll do them one at a time. It's probably the easiest way. So we're going to take positive first here. So if this is a positive 5, it's 150 plus 560k. I'll do the other one over here then after, which would be 2, 3, 4 minus 52k is equal to negative 5 times this. So that would be minus 150 minus 60k. So there's our two situations there. So again, just to be clear there, I'll do this with color. So the positive is this one, and the negative is this one here. Okay, so that's meant to be 60k there. Okay, so 2, 3, 4, bring the 150 over, becomes a negative. Bring the minus 52k over here, becomes a positive. So we end up with 84 on the left is equal to 112. Okay. So K is equal to 84 divided by 112. So 84 divided by 112 is 3/4. So that's our first K value. And the other one then would be found from this equation. Bring minus 150 over, becomes positive. Bring this negative 52k over here, it becomes positive. So this time we've got 2, 3, 4 plus 150, which is going to give us 384. And that's going to be equal to minus 60k plus 52k, which is minus 8k. So dividing both sides by negative 8, k will be equal to 384 over negative 8, which is negative 48. So there's my two values for k. The two possible values for k as they asked there. Part 2, if k is greater than 0, find the distance from P to L1. Okay, well if k is greater than 0, it's this value of k, 3/4. So k is 3/4 if we're taking the positive value of k as it states. And the distance from P to L1, if you remember, was this here. So it was 18k, modulus of 18k, sorry, modulus of 18 minus 4k all over 5. So we're just going to substitute 3/4 in here for k, and that gives us the modulus of 18 minus 4 times 3/4 all over 5. And you can do this in your calculator. That gives you a value of 3. So the distance from P to L1, taking the positive value of k, is 3. And that is the end of the question 3.